This is CPM Precalculus Chapter 2, Number 3. So here's another piecewise function. F of x is defined to be x squared plus 2 for x is less than or equal to 1, and 2x plus 7 for x is greater than 1. So first in part A, we're asked to fill out the table below for y. Okay? So for x is less than or equal to 1, that's over here. We know that the x value, whatever it is, the y value is equal to x squared plus 2, right? So when we have the x value, negative 5, well, what is going to be the y value? It's just negative 5 squared plus 2, which is 25 plus 2 is 27, okay? Negative 4 squared plus 2, right? We're just plugging in the x value to get our y output. Negative 4 squared plus 2 is 16 plus 2 is 18. Negative 3 squared is 9 plus 2 is 11. Negative 2 squared is positive 4 plus 2 is 6. Negative 1 squared plus 2 is 3. 0 squared plus 2 is 2. 1 squared plus 2 is 3. Okay, so that's filling out this side of the chart. Over here, we're just continuing, but we have now x is greater than 0. That should be is greater than 1. Let me go ahead and erase that and fix it. Right, it's greater than 1. And the equation is y is equal to 2x plus 7, right? So at 1, we know if we plugged it in there, 2 times 1 plus 7 is 2 plus 7 is 9, okay? We plug in 2 in this equation, we get 2 times 2 plus 7, that's 4 plus 7 is 11. 3 times 2 is 6 plus 7 is 13. 4 times 2 is 8. 8 plus 7 is 15. All right? 5 times 2 is 10. 5 times 2 is 10 plus 7 is 17. 6 times 2 is 12 plus 7 is 19. 7 times 2 is 14 plus 7 is 21. Okay? I also noticed that we're going up. We're adding 2, adding 2, adding 2, right? 7 plus 2 is 9. 9 plus 2 is 11, plus 2 is 13, and so on. Okay, and that makes sense because this is the equation of a line, right? 2x plus 7 is just a line with the slope of 2 and a y-intercept of 7, right? So let's go ahead and go on to part B. Part B, we're asked to sketch this function. Okay, so given all these points, okay, so the first point we want to sketch is negative 5 is our x value and y value is 27. So negative 5, I go to the left, negative 5, 1, 2, 3, 4, 5. That's negative 5, but up 27. So I have a point right here. Okay. If you notice my y-axis, each tick is 3. So I go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. So you'll just have to notice you can do your vertical axis with any increment, right? But here I chose to divide it by 3 each time. All right. The second point is negative 4, comma 18. So I go negative 4 and up 18. Right there. Then we get negative 3, comma 11, negative 3, comma 11, right there. Negative 2, comma 6, negative 2, comma 6. Negative 1, comma 3, negative 1, comma 3. 0, comma 2, 0 right here, comma 2. 1, comma 3, 1, comma 3 right here, right? And if I sketch this using I can connect the dots, right? I'm going to get what looks kind of like, whoa. Let me just sketch each one simply. If I connect the dots smoothly, right, it's going to look similar to a parabola, right? And if I look at the equation, this right here is just the parabola function, y equals x squared, shifted up by 2. Okay? So when we graph that, it kind of looks like this, but we're cutting it off here at x is equal to 1, right? x is less than or equal to 1 is where we wanted to find, so that's why we're going from x is -4 to +1. Alright, so now let's go ahead and graph the rest of the function. Over here, at x is 1, y is 9, right? So I have 1, and the output is 9. At x is 2, y is 11, so 2, 11. So here, x is 3, you get 13, 3, 13, right? 4, 15, 4 up 15. 5, 17, 5 up 17. 6, 19. And 7, 21. Okay? And like I expected, this part is just a linear line, right? Oops. These all go through like that. Okay? And one thing to note, they even give you a hint. Recall the use of open circles. So open circle like this to indicate a point that an endpoint is not included, and a closed circle, like if we shade it in, that's a closed circle. That means that the endpoint is included. Okay? So which endpoints are not included? So what we have to be careful now is greater than 1. Right here, greater than 1. We know that at x is 1, this point is not included, right? This should be, instead of a closed circle, an open circle, because there's no or equal sign, right? So that means the point 1, 9 here, 1, 9 is an open circle. Draw it like that, right? So that's an open circle, whereas this right here at 1, 3 from over here, that's a closed circle, okay? So open circle, closed circle. Okay? So that's the end of part B. We just sketch it. I should put both of these in the same color because this is all together making up f of x. Okay? So I used two colors to show you that there are two pieces, but the pieces go together to make one function f of x. Right? So our function is defined in pieces. Okay? So let's go on to part C. It's just asking us, what is the domain and what is the range of this function? So remember, the domain is all of the x values that give us a y value. Okay, so we have to look at, first let's look at the end behavior. If we go, if we look at the left and going up, right, at this function, that means it's going up forever and left forever, right? So that means over here at x is, I don't know, -1000. We're going to get a y value all the way up there, right? Because there will be an output. So the domain we look at -infinity, right, to +infinity, and what x values give us a y value. So yes, starting here, yes, 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 all the way we have points in our domain. Right here we have values. The only questionable one is right here at x is 1. Well, remember, this is a closed circle, so even though this is open, we have a point at x equals 1. It's just here at 3, right? So we have a yes. We keep going. We scan across. Yes, yes, yes. Draw vertical lines. Yes. And this arrow means we're going to the right forever and up forever. So that means the domain is just all values of x. There's always a y output. Okay, so that means from -infinity to +infinity. Okay, looking at the range, remember we're just going and looking at for every y value, so looking at the y-axis, what values of all the y values that give us an x output. Okay, so at -9, we could see if I draw a line here, does this green line at -9 pass any of our points in orange in our function? No. So we have no x value at y is -9. How about at -6? Still no. We have to keep going up until we hit this point right here. Right? And what is that point? It's right here is our first y value. And we can go ahead and look up on our graph. We know that x is 0, our y value is 2, right? So scanning up, we know that the range starts at 2. And then from 2, we go up, yes, 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 we keep going up. There's 2 points left and right. 2 points, right? And these arrows mean it goes up forever as well. So it goes from 2 to infinity. And all we have to remember is this point at 2 is closed. So that means we have a bracket. Okay? So that's the domain and that's the range of our function f of x here in orange. Alright? So that ends CPM Precalculus chapter 2, number 3.